In this project, a shower drain inside an inclined channel with 120 water input is simulated. A shower drain inside the inclined channel is simulated and analyzed by ANSYS Fluent software. In order to analyze the air and water flow inside the channel, a standard model with the use of a standard valve functions is exploited. A multi-phase VOF model has been used to investigate the two-phase flow of air and water within this channel. The geometry of this project is designed in ANSYS Design Modeler and meshed inside ANSYS Meshing. The mesh type used for this geometry is unstructured. The key assumptions considered in these projects are: simulation is done using pressure-based solver. The present simulation and its results are considered to be steady states and do not change as a function of time. Also, the effect of gravity has been taken into account and is equal to -9.81 in y direction. Using a scale mesh section, we can see the dimensions in all three directions. And also we can view the length unit that it is meter in the CFD simulation. From the mesh display section, we can display all the boundaries and surfaces that are related to the inlets, outlets, and walls. There are 120 different water inlets at the top of the channel. Also, there are two outlets, one main outlet and one the side outlet. And also we can see the main wall and the nozzle wall that the inlets are placed on it.
You can buy this learning product to obtain a geometry file, mesh file, and a comprehensive training video on how to set up, meaning the pre-processing, solution, processing, and extracting results, which is the post-processing and analysis.
We can obtain all the contours, including pressure, velocity, and phase, volume fraction contours on the plane that we will make. To display our desired contour, the first step, we should make a surface. Following this path, we can see the minimum and maximum magnitude in the Z direction, and the best surface to have the two-dimensional contour on that is the Z surface in the middle of the channel. Now we made the plane or the surface, and we are going to show every desired contour on that. Here we can see the volume fraction of the secondary phase, that is water. And also we are able to obtain the velocity contour. Suppose that you are going to obtain the, for example, the velocity magnitude at the outlet boundaries. Follow this way and obtain the desired report. As it was predictable, the velocity magnitude at the main outlet is more than the side outlet.
To benefit from Mr. CFD services, including simulation, consultation, and training, contact our experts via info@mrcfd.com.